So, in the previous classes, we discussed about various CNN architectures. We talked about AlexNet, then we talked about VGG, mostly 16 and 19. Then we talked about InceptionNet, ResNet, and later versions of InceptionNet. And finally, we talked about Inception ResNet. So, obviously, I know that the more important things are usually Alex, VGGNet, Inception, and ResNet, but sometimes it is good to know the later versions of InceptionNet as well. The reason why I am saying this is because AlexNet and VGG 1619, you might get questions from them, but they are not used a lot anymore. So all these other networks, they are used, and you at any point of time might get questions from anything, and you may not be prepared. Hence it is important to know about all these architectures, like I keep saying. So Inception, the later versions of InceptionNet, we know about the other things, right? We are not going to get to that. So the later versions of InceptionNet, I would say that make notes about it, create kind of columns and everything, write neatly, and with every different version just write properly what do you think are the pros and the cons, and how the next version is better than the previous one that was happening. Okay, so this is the whole thing, and I think you should make this kind of a task or something and describe, and don't do that just for InceptionNet. Start with AlexNet, and then for every network, start with writing pros and cons and other different architectures. Make some bulletin summary points and understand those, and then for each of those keep doing that. So the thing is, once you have all of that written, you might not have to go through the video again and again. What you can do is you can go through the notes, and then you can just understand what is happening, and maybe very briefly, like for 5 minutes, go through it, and everything will come into your mind, because I know there are so many architectures you are bound to forget. I mean, that is human nature actually. So today we will be discussing about different types of ResNet, later versions of ResNet actually. So obviously Res stands for residual net. So the thing is, ResNet, the main important thing or important structure about ResNet was when it got added with InceptionNet. Okay, so this was the main actually version or advancement of ResNet when it was Inception ResNet, because they actually proved and gave really good results, better than most results. So we have already discussed about this, and this is one of the versions that, even though I included this in as later version of InceptionNet, but this can also be included as a later version of ResNet, right? You have ResNet, and then you add InceptionNet to it. So that was one of the versions. So we have already discussed about it, so we'll not go into the details, but next we'll understand some other few things about ResNet. Okay, so this was in the original paper of ResNet. When they took the original paper out in ResNet, what they did was they tried different things, different weights, and different places where they added normalization and addition and activation to see how different models were adjusting. Okay, and this was where it happened that they found out the best way to make a residual network was adding activation after you have done the addition, and then having two layers and skipping that. So that was the whole idea of this, right? You have this, then this, you have an addition, and this is followed by a ReLU, right? And then you have f of x here, you have x here, you have a ReLU here, you have weight and weight. These are two layers obviously, and then this is the skip connection here, and this is followed by a ReLU. So this was the whole residual idea, the whole block of residual thing. So this idea actually, that adding ReLU after or before and everything, this came through this random experimentation. What happens is, earlier what we used to say was these models, these modules, were kind of like black boxes, or these models, these architectures. So the reason why they were known as black boxes was we did not know exactly what was happening in the inside, right? So usually at times we know for the first filter it might happen that it finds out edges, but we don't know how other features will be extracted, what features will be extracted. So it was known as, these architectures were known as black boxes or mystery boxes. So this was the only reason why it was known as, because we did not know anything. Now we know a lot about it, so now it is less of experimentation. Although experimentation is involved, it is less of experimentation, but at the same time we have a lot of theory to support our reasoning of why we are doing this. Okay, so this is the original ResNet, the skip connection, the whole module addition, then you follow it with ReLU. This is the skip connection here, and here you have weights, batch normalization, ReLU, weights, batch normalization. Okay, so this was the whole thing. This is, you are doing batch normalization before addition, after addition, sorry. So you, here what you were doing is you were batch normalizing, then you were adding the whole thing. Here you are adding it and then you are doing batch normalization. So these were different variations that were tried out actually, and then this was the one that was found out to be the best. Then you have ReLU before addition. So like I said here, the important thing that I keep mentioning all the time is they use activation after adding. So they have actually tried out here where they use addition, and before addition they have tried out ReLU. So it's not that this is like randomly they have come with it, they have actually done a lot of experimentation, and only then are they able to come up with this. So now that this is all done, okay, ReLU only pre-activation. So here you have no ReLU, and then finally full pre-activation ReLU, like you can see you have addition, and then you have no ReLU. We have batch normalization and everything, but there is no ReLU after addition. You can see that, and then there is also no batch normalization in the end. So these are different things that have been tried out, and this was in the original paper. So I thought since we are discussing about different versions of ResNet, let us look into different residual modules that have been created over time and at the same time, and this was hence found out to be the best one. Now this we will be discussing is ResNext. So this is basically another version of ResNet. Here you can see this is not like a very big thing or very big detail, it's not used a lot, but it was there, so I thought why not add this also. So this is basically, here you were going down and down, and then you were adding a skip connection. Here what you are doing is you are trying out even the wider part of it. But this wider part is different from the actual part that we were using in inception blocks. You have a skip connection, right? But here the wider part is different. The reason why this is different is because if you will look properly, here you have nothing of any inception modules kind. So what were the inception modules, if you remember? So inception modules were more like 1 cross 5 with 5 cross 1, or something like 2 3 cross 3 instead of 1 5 cross 5 and other stuff like that. So it does not have any of those. So here you have 32 different paths, and then you add the whole thing up, and then finally you add the whole thing up with the actual input, the skip connection here. And then there is also one more known as densely connected convolutions. So densely connected CNNs are basically residual blocks that are being added to CNNs. Now this is not that important, so I did not put any picture or anything on display to make this understand. So ResNet's the main thing, important version of ResNet that was actually evolved ResNet was actually Inception ResNet, and we have talked about it. But then there is also a ResNext, so that is why I talked here about this. And other than that, there is nothing much about it. We different talks about different modules of ResNet, but yes, this one was the best. So that is it. In the next class, what we will do is that we will talk about something known as transfer learning. But that is for today. This is a small video, so keep enjoy your day and keep learning.